Hello everyone, welcome to next video tutorial on linked list. In the last three videos, I have explained the concept like what is single linked list, how to perform operations on single linked list. Then in today class, I am going to explain other different operations on linked list. Like earlier we have seen how to insert, how to delete, how to display, but today we'll see many other operations like finding the length of the list, then search for an item in the list, then concatenation of two lists. Like the first one, finding the length of an list. In this list, it contains four nodes. I have to display at the end of the program. The list contains four nodes, or you can say four items. So how to get it? Initially, like I said, in the single linked list, always the first node will be held by the first variable. Okay. In order to keep track of all the nodes, I'm just making use of an current variable. Current holds the first. I keep on incrementing the current variable until it reaches to the null. How to perform this? If current pointer link not equal to null, okay, then current equal to current pointer link. Initially current pointer link not equal to null, move to next node. Similarly here current pointer link not equal to null, keep on doing this until it reaches to current pointer link equal to null. That time we get the last node. Once we get last node in each point, and we have to increment the count. Like initially this is a function finding the length of an linked list. So I'm taking current variable. Initially I'm taking count equal to 0. After visiting each node, I'm going to increment the count. So like if the list is empty, I have to write first equal to null, return 0. If list is not empty, then we have to what you have to perform, current equal to first, then get the last address of the node. Then by visiting each of the node, initially current equal to current pointer link is not equal to null. That is why it is incremented to count will be incremented 1. Keep on when the current pointer link reaches to null, that time it will come out of the loop. Whatever the count is there, that will be displayed. Like now the count will be 4. Then next operation is search for an item in the list. Like in this given list, I'm going to search for the 20 element. I can say 20 item. That will be an key element. I am searching in the given entire list. Okay, like I have to check this key with all the elements of an list until it reaches to the null. Okay, then wide search node first. By default always the first will be the node of a linked list. Then searching for the key, write int key. Then if list is empty, return 0. If list is not empty, keep on increment the current pointer until it is to the null. In between that, compare with the key. Okay, while current not equal to null, initially uh, either you can write a current pointer not equal to null, or you can write current pointer link not equal to null. Both remain same. Then we get inside the function because the first is not null. If key equal to current pointer info, key is 20, current pointer information is 10. Is it equal? No. Then increment the current equal to current pointer link. It will come to next point. Again key matches with 30. Is it equal? No. Again current equal to current pointer link. It will come to third node. Key is 20. Current will again apply here. Current equal to current pointer link is 20 now. If it is equal, 20 equal to current pointer information is 20, you have to break, come out of that. Okay, then you just display print search is successful. If keep on increment the value, it just none of the value get match here. For example, if I take a key equal to 50, it matches all the value, and the current value reaches to the null. Nowhere we found a matching, then we display unsuccessful search. Then third one, concatenation of two lists. Like here I taken the first list and second list. First list contain 3 node, second list contain 2 node. And first list ends with null character, second list also ends with null character. And the first list I'm taking, the first node will be hold by first variable. In second list, first node will be followed by the second variable. Then I'm going to concat means at the end of the execution I want to get the answer 10, 30, 40, 50, 60 like this. Okay, both will be get added. So initially if first equal to null means this first list is empty, then this becomes the only list in the only values of nodes in the list. That time we have to return second. If second is empty, then this becomes only the list, return first. If both are not empty, then we will start from current equal to first here. Current equal to first. Again, we have to keep on searching until it is to the where I'm going to concatenate. I'm going to add the second to the first list, end of the first list. So first get what is the end of the first list by making use of obtaining the address of a last node. Initially current will be at the first, current equal to first, current pointer link not equal to null, keep on increment until the current reaches to null. That time we got the last address, the address of a last node. Then we replace this null with uh, and attach this link with the second one. So how to do that one? Once we get the final one, current pointer link, that is current pointer link is equal to second. Now this null will be removed, this connection will be given to second. Then by default we have to return first, like entire list always first will be the initial node. Okay, we're returning first here. Then next operation is singly linked list with header node. Like in the earlier example, all the singly linked list operations are always start with the first node. But now I'm taking that first node replacing with the header node. Okay, the name itself indicates the head is the first node from where the single linked list gets started. And head contain two fields like information and field. Information field is always empty, and if it is only the one node is there, that time link field can be a null one. If more number of nodes are there, then this link field contain the address of the first node. Like here, head pointer info is empty, head pointer link is contain the address of the first node. If it is not empty, because if only one header node is there, then no other nodes are there, that time head pointer link is null. And or you can say head pointer info, as I told, it does not contain any information. But if it contain the number of nodes in the linked list. Like here 1, 2 and 3 nodes are there. This can represent the number of nodes in the list. Okay, then advantage of header node simplifies insertion and deletion operation. Like earlier what we are doing, to make use of insertion, we have to make adjustment with the first node, but here it is not required. And avoid usage of various cases, such as if only one node is present, wherein while performing all the operations single linked list, uh, first case is we are checking for empty, second case is we are checking for if the list contains single node. That case can be removed if I use the header node. Okay, we can reduce that number of cases. And design of program is simple. And last operation, circular linked list with header node are frequently used instead of ordinary linked list, because if I use ordinary linked list, the number of cases will be more. But if I use header with the linked list, that time number of cases we need to check is less. Okay, then just take an example here. Earlier in the single linked list, head will be the first will be the first node. By using this you can access any of the nodes of a list. But now head is the main node. By using this we can access any other nodes of an uh, singly linked list. Like we are performing different operations as we have done in the single linked list, without header node. Same operation you have to perform using header node. Like initially we have to perform insertion from the front end. Okay, so this is the list we what we have. I want to insert the element. As I told earlier, whenever you're going to insert the element from the front end, directly the temp will be the first node. But in this example we need to keep maintain that the head will be the always the first node. Okay, so what is the first step? Create a temporary node and insert an item into it. So how to create the node? Like whenever you call get node function, the node will be created. For that I am giving the name temp. So this temp is created. Once the temp is created, information field I am writing 60. Temp pointer info equal to item. I'm not going to write null because I'm going to attach to the uh, first node. So no need to write null here. Okay, if it is as rear end, that time you can mention null, but if you're adding it as a front end, because in the front end that 60 will be added at the end and contain the address of the first node. That is why null is not mentioned in the link field. Then just look at here, in this example, head will be the node, first node is already, this is the existing one. What I'm going to add, I'm going to add the temp between pair to pair between head and between first. I have to bring and keep it in between them. So what to do for that? I need the address of the first node first. First node. So first equal to how to get? First is head pointer link. That will be obtained by first equal to head pointer link. Once we get, we have to bring that temp to the in between. Make this temp node as an first node. So what we do? Just head pointer link. This link will be removed, and head pointer link will be given to temp, and temp pointer link will be given to first. That becomes, we are just pulling this temp between the head node and first node. Then return head. Always the first node with the header node. Return it. Okay. So all the five steps are written. As we have seen, all of them are written inside a single function. Node insert front, item what we are inserting, and earlier is taking the node first, but now we are taking node head. Okay, then remaining two operations I will explain in the next video.